HVAC 360, episode number 67. Lessons learned. Electrical coordination. Hey, welcome back to another episode of HVAC 360. I'm your host, Matt Nelson. This week we're going to be talking about some electrical lessons learned, some things that I've learned in the field, and I just want to be able to share those with you. Sometimes, you might be like, well, why electrical lessons learned? Isn't this HVAC 360, not electrical 360? Well, okay, just relax. Basically, what I want to be able to do is there are some things that happen in the electrical world that, relate to mechanical, or you can use it as a kind of a cross-training platform where you can kind of identify things that are happening wrong in one discipline and being able to and then it's not even wrong, I guess that's a misconception. It's not wrong. It's just poorly coordinated. It doesn't go as smoothly as it possibly could. And that's kind of what I'm here to, to kind of identify that for you and kind of flag it. And maybe you can use it and bring it into HVAC. And because there's a lot of different things that are commonalities in what I'm going to be talking about and things that go on in HVAC. So, but first, before I hit that, let's go into thank our sponsor. Again, it is the Building Commissioning Association. I'm so happy to have the Building Commissioning Association sponsoring HVAC 360. If you're involved in the commissioning aspect of the built environment at all, the BCXA, they're where it's at. So if you want to get networking, you want to get training, you want to do conferences, this is the first stop shop. I'd encourage anybody who is being that is their livelihood, being a commissioning authority, go to the BCA's website at bcxa.org, sign up as a member. Have your company join. One of the things that's coming up as far as training, their spring webinar series is winding down, but you still have one more chance to be able to kind of access that information, and that's June 19th, 2013, is going to be the commissioning of grounding systems for mission-critical facilities. Again, these are kind of some of those facilities we're talking electrical here. You really can't get wrong, because if it goes wrong, then it's really bad for everybody. It's one of those things where they trust professionals, like professional designers, professional contractors, and professional commissioning authorities to be able to identify and make sure that all the building systems are working correctly in the first place. So if that's something that you do as a matter of daily practice, check it out. Or again, even if it isn't and it's something of interest, go ahead and just kind of sign up for the course and learn from that, because there's a lot of things that you can apply in different ways to what you do, even if you're not dealing with mission-critical facilities all the time. There's always some good lessons to learn. All right, so let's get on to our show. All right, basically, I want to be able to raise the awareness. This is not really always kind of tales with happy endings, shall we say, because some of them don't get resolved, some of them are kind of poorly resolved. But I just want to be able to identify and share at least some things that I've seen with the rest of you, my listening audience. And I want to, hopefully you're going to be able to gain something from that. So I'm going to start off by talking about, let me take one more step back and make one more point. A lot of these issues fall down to missed coordination. And they really, once that happens, and it's something that has to take place but didn't take place, it's a matter of, okay, who pays for it? And typically you don't find these, it's really the commissioning authority's job to be able to find these in the design phase. But sometimes you don't, find them until the construction phase. And at that point, it's contractor to contractor looking at each other going, all right, who's going to pay for this? And it tends to escalate and get heated rather quickly, because really, somebody's going to get screamed at, somebody's going to get yelled at, somebody's going to have a bad day because it's going to come out of somebody's paycheck one way or the other. It's when you're an engineer, you get kind of isolated and insulated from these types of feelings and these types of discussions, but they go on all the time because cash is king in the contracting world, and nothing gets done without a dollar sign associated with it. So that's something that's really hypercritical that doesn't get passed by quickly or easily. Really as an engineer you should know and be aware of, and as a contractor you're like, yep, absolutely. I can't even I can't even do anything without a change order being signed. So, but let's go into the first lesson learned that I want to share. It's about exterior lighting coordination, and this is exactly what I mean by it's a coordination, and you have two contractors looking at each other, going, "Okay, exactly who's going to pay for this?" Because it didn't work out in scheduling, and I guess let me start by explaining the situation. So the electrical engineer had drawn exterior lighting in some overhead soffits. These are soffits that kind of extend past the exterior wall of the building that face down, so you can do some nice lighting around the exterior of the building. So, but they're can lights. They point down, and they're installed in soffits. Well, they're on the electrical drawing. So the electrical contractor, he had them ordered. He had them in his price. And when you look at the architectural plans, and this is something that happens a lot, and there again, this is where you kind of apply it to your own, apply it to your own business and discipline. The general contractor did not see this because they weren't on the electrical drawing. So he went around the exterior of the building, and he installed his soffits, wherever and whenever he saw that they were on their architectural drawings. And so when the electrical guy goes, "Hey, you got to cut a hole for me," he's like, "I gotta cut a what?" They just stare at each other and go, "Okay, well, who's going to pay for this? I got to have a guy." It's like they don't happen by magic. I have to physically pay a guy to go out and cut holes for each one of these downlights, one of these exterior can lights. And if you need access to any other places, say you have electrical conduit coming through the wall where you need to get access to temporarily to be able to kind of wire these things, that's additional holes. And it's not only that, it's patching. It's there's access doors that might be involved. So there was this big discussion about exactly who pays for all this and where it's going to go. And again, it's like the electrical contractor says, here's my set of drawings. I got my blinders on. I'm just looking at that. General contractor is doing the same thing. The electrical engineer and the architect didn't kind of cross coordinate, and everybody kind of had their head down. If they only had shared, okay, hey, I need to put these in ahead of time, it probably could have just gone away. It probably could have been handled, as they're putting it up, they put in an extra hole, not a big deal. They have a guy in there anyway. So, but after they had it installed, and the electrical contractor was a little bit late, his fixtures got delayed, so he was a little bit late to the party, and he didn't bother coordinating that with the general contractor. And obviously, the construction manager, the owner's rep is sitting there going, "Hey, the owner's not going to pay for it. It's on the drawings. It's either the contractor is going to pay for it or the architect's going to pay for it." And typically, these things, unless it's a serious issue, don't necessarily get escalated to have the architect pay for these things and go to the engineer rather, either or. And have them go to some sort of errors and omission insurance. Most of the time it's going to be handled by the contractor, which, there again, is it fair? No. It should have been coordinated before that. All right, let's move on to the next one. Here's one where we had a air handling unit that was put on the roof. And the one end of the air handling unit, which it sometimes happens, basically the one end of it is all sort of electrical connections, controls connections, and in the U.S. it has certain safety requirements. You have to be back a certain number of inches, clear from these panels. So really, what what needs to happen is that you should actually show it on the drawings. Really, as far as the commissioning authority goes, I would say, hey, you know what? Draw a dotted line showing the clearance from this. So I guess the one thing when you put a unit on a roof, the first thing that architects wants to do is cover it up. They say, this is kind of blasphemous. It's doesn't match with the architectural design or the feel of the building. Let's cover it up. That's the first thing they got to do. Well, they don't want to pay for extra screen wall, so they want to make it as tight to the unit as possible. Well, in this case, we had a unit that it ended up being 24 inches away from the screen wall, from the end of the unit. So you had actually two problems that compounded each other. One, you didn't have the access, couldn't swing open. It would actually hit the screen wall, so you couldn't open it up fully. And the second thing was that you couldn't, for the electrical disconnect, the disconnect was actually on the side of the unit, which had enough space, but you'd still have the electrical feeder coming up in that end unit with only 24 inches, and that's against code. And everybody was saying, hey, you know what, we got to change it. I mean, that's one thing that when I was looking over the design, I flagged. Did it get picked up? It got picked up, and it got talked about, and it got talked about again. And the engineer, he thought that the unit was actually the other way around, which, if it was, it would have had a lot of space, but it didn't end up being that way. And a lot of times, depending on your situations, you could end up, what tends to happen is units, they don't necessarily get bigger in cross-section. Depending on the manufacturer that's specified and what actually gets ordered, they actually kind of grow and shrink in length, depending on the sections and how big those sections are. So that can kind of be variable in your design. So you got to be really hypercritical about exactly where that is, where the electrical disconnects are, and being able to safely access those. Because obviously, this is a safety issue. The electrical inspector is not going to pass, say, oh, you're good, you're just good. We're okay with 24 inches, because it is a safety issue. You have arc flash, you're dealing with, the 483 phase. And so he wants to make sure that everybody that's working on this unit is, properly safe, per code. And obviously we couldn't move the screen wall because, that's something that gets set in place, real quick. So at least, the one good news about this story is that, and it hasn't been resolved yet. I'm currently working on it, but it hasn't been resolved yet. But at least, the electrical connection has not been, fed into the unit. So if there's something that we're trying to get the electrical, here's what we're doing to kind of resolve it. We're trying to get the electrical inspector, as he's going through other inspections in the building, to come take a look at it and to actually give us a yay or nay, or, here's what I'd like to see you do in this situation. Because we still have some flexibility to be able to solve this problem and have it be resolved without any issues. So, again, that one does have some electrical or HVAC relevance to it, but you can see that, with accesses and making sure that the clearances are right, it plays a critical role. You just, you're limited to the amount of space that you're given by the architect to begin with. You can't take that for granted, and you can't just say, oh, I got space to give, when actually that's, safety clearance for, some sort of electrical connection. All right, next one, wall boxes. Wall boxes, if you have, say for instance, if you have either a building that's, the internal spaces are made out of concrete masonry units, the CMUs, those tend to, when you're putting them up, they'll have, obviously, because, pretty much any building will need, outlets and wall switches. They'll need those to be installed, in the concrete block. And here's more of a coordination issue than anything else, because if you use those, if you coordinate, between the two trades, you'll be able to get a better product. And here's what I mean by that. Say, for instance, you're the mason, and what you do is you install block. Your job is to install block where it shows on the drawings, and it's supposed to be, straight, and it's supposed to be plumb, and that's your job. So you go guns a-blazing. Once you get the green light to go, throw down your block and to get those erected, you're not stopping for anybody. And because obviously that's you're paid there to be very efficient and get that block up. Well, if you put the block up and you didn't account for the fact that, hey, I need an outlet here and a switch here, those tend to be you need to have a metal box and a conduit coming out of the top of it, at least to get it up into the plenum space, into the ceiling. If you are a electrical contractor and you're caught flat-footed and you have to go kind of put it in after the fact, you might be using some sort of flexible conduit, some Romex. I'll just say, I don't know if it's Greenfield, but you'll put in some flexible conduit because you really can't get a stick of pipe down that far into the wall for, say, a floor outlet or for a wall outlet that's low to the floor. So you're going to have to kind of retrofit that, and you're going to end up busting up the block, and it's all in all, it's not going to be pretty. But the fact is that if you coordinated and you prepped ahead of time with the mason to say, hey, you know what, I have these outlets that are here, here, and here. Can you throw it in for me? Because you can actually pre-make the metal junction box, the box for the outlets with the pipe going up, and that can actually set them in place for you as they're going up. If you work out a deal like that, you can actually have them do that for you, and in a lot of cases that makes a lot of sense because you get a cleaner installation, you get a better coordinated installation. You just have to be there to make sure that everything's getting coordinated correctly, because there again, if you tell them something wrong, they're not going to know any better as far as, because they're not electricians, but they will kind of as you go along, they will fit things into their masonry as they put them up. So that's another thing. I say this, and it's coordinated and it's things like that, but really it's a matter of construction, and that's one thing that you really don't have a good feel for, especially being a younger engineer. You don't know exactly what comes before what and how quickly things happen. Just to kind of it really is one of those things that it seems if you visit a job site, it may seem that nothing happens for a long, long time. But when something gets green lighted, where you can start putting up block, you can start putting up the interior drywall. Once they get the green light, these contractors go to town, and you do not have 2 seconds to waste if you want to get something coordinated, because you really need to be on the ball. So it's just one of these kind of this speed to the next stoplight kind of things with the contractors, just to make sure that they get an area done and they get it out and they get it ready, so they're not holding anybody up. So let's move on to the next one, floor boxes. This one was it's a little bit tricky. It actually had more to do with technology, but I kind of shoved it in here with electrical to begin with. Just to start out the conversation by saying drilling holes in concrete floors is expensive. It's not prohibitively expensive, like, oh my gosh, they never do it. But it's expensive in the sense that, if you have to drill an extra one, it really is, it's a significant price. I don't know exactly what it would cost, but, if I had to throw a number on it, maybe $1,000 or something like that. But, it is expensive to have somebody drill through a concrete floor. Maybe not $1,000, but it just seems anything in construction, what does it cost to change? Oh, it has to be at least $1,000. Sort of like a running joke. But putting something in the floor is a very specific, very demanding, and a very exacting kind of thing. So what happens if you get it wrong? What happens if you have a floor box that you ordered and it's one size, and then it comes into the field and it's another size? Essentially you have to re-drill all these floor boxes. And depending on how many floor boxes you have for these inlets and outlets, it could vary from job to job. But that's exactly what happened. Is that the design was designed around one specific floor box, and they got a different type of floor box. So they had some issues, and I think they had some scrambling around to do, and they finally got a floor box. But now they got one that fit in the hole, and there was also, if you have floor to floor, you have some issues about fire stopping. If that's your type of construction, you have to be really aware of fire stopping and how that fire stopping is addressed in that floor box, because again, it's a hole through a penetration, and a lot of times that floor is a fire rated assembly. So, moving on to the next little bit. So now that you got the floor box in and it's appropriately fire stopped between levels, now you got to get the cabling in. So this became the next issue: getting the cabling in. Was there enough room in the box? Was it too shallow? Was it deep enough? Another thing is that okay, and this was chocked full of different data cables and power cables and things like that. And each one had a number of outlets. So you could actually technically get everything to fit, put it in place, but it's one of those things where the connections were angled, so you might not necessarily get all the different, you couldn't plug everything in all at once. You might have to, plug in just a couple of things. So, there again, it's one of those things that has to be thought through. You ended up with, something, and there was a big discussion about, exactly, how you could make it fit and how it would face and what the orientation was and was it the right thing. And they went over and over again with this, and they finally got it resolved. But, there again, it wasn't cheap, and it was one of those things that, as a contractor, you don't really get paid to sit around and think about different solutions to problems that you have. You tend to have enough money in there to, buy the parts that are specified on the drawings, put them in once, test them, and you're good to go. That's what you have money in there for. And then, if that doesn't happen, if there's something that you say, well, it's a means and methods, I'm just going to put it on the electrical engineer or the electrical contractor to figure it out. You know what? Sometimes that's not really fair. It's taking away from their bottom line. You're taking the easy way out by putting generic notes on drawings and saying, hey, they're going to fix it in the field, when it's something that you could have thought about just a little bit more and kind of maybe detailed out and been very critical, because it's easy enough to say, okay, I'm going to put these 10 outlets in this hole and put it on a plan note. But if you can't do it in reality, then you're kind of doing a disservice to your profession, and you're really trying to pull one over on the contractor if you don't have that thought through all the way. So just ask somebody if you have any questions about exactly the orientation and can you actually plug everything in, because I know that's been an issue. So one more for the record books. Another one that I had, and this always gets me, definitely a classic. But it's about being rushed for a job. You're behind as an electrical contractor. You're trying to get caught up, and you need the electrical inspector to pass you. Otherwise, you're going to hold up a lot of other work. And this happened on one of the particular jobs, that the electrical contractor said, okay, I know that if the electrical inspector is going to go around and he's going to look up in the ceiling, he's going to see junction boxes open, that he's going to flag it and he's not going to pass me for an above the ceiling inspection. And if you didn't get if you couldn't button up the ceiling, then the finishes couldn't go on. There's a ton of other work that you can be held liable and responsible for. And this one, if you do that, when I say holding up work, that should equal back charges and delay claims to you. That should send off some big bells and whistles. Again, people, when they get the green light, they like to go, go, go. If somebody stops this train in the middle of their go, 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 they have to get paid, because they have people that are just sitting around waiting to do work because you've already coordinated that. And again, big money issues, a lot of angry people, a lot of unhappy contractors. So you got to be able to make sure that happens. So what they did to solve this problem and solve, I'll use loosely, what they did to get past the inspection, let's just put it that way, is they covered up all the outlets, and they closed up all the junction box covers so everything looked right. If you didn't open it up, there wouldn't be a problem. And you know what? The inspector went through. He thought it looked fine, and he passed them. And so, you know what? The train kept going. Nobody got delay claims. Nobody got back charged. They kept going. Fast forward to the end of the job. What happened, you might ask? Well, we'd go into a room and we'd be like, where are the outlets? We'd look around at the wall, and we'd look at the drawing, and we go, you know what? There's supposed to be 4 outlets in this room, 1 on each wall. There are only 2. What happened? Well, I tell you what happened. The drywall guy, the electrical contractor, never coordinated with the drywall guy, and the holes never got cut for the outlet boxes. Yeah, there were conduit in the wall, but there wasn't any spot to cut the junction or the boxes for. Also, we'd go through and we'd plug in our outlet testers, and there'd be no power. We were like, is the circuit not on? No, everything at the panel is turned on. Come to find out, guess what? They closed up all those junction boxes in the ceilings. They didn't have any wiring in them. So they had to go back through and basically, rewire, reconnect, finish their work after the fact. And, it probably took them 10 times as long to finish their work as to actually get it done in the first place. But, that's all on the electrical contractor. That actually had nothing to do with anybody else except for the electrical contractor. So the lessons learned there is, hey, you know what? If you have somebody that's behind, pay especially close attention to those contractors. There's more than likely going to be a situation where they didn't do the right thing, or they were trying to take a shortcut, or somebody forgot the coordination. You'd get up, because ultimately the work is directed by a project manager, and when the project manager gets stressed and he can get forgetful, and if he's not kind of an A-team kind of guy, if he's not the best that the contractors have, and you end up with a B-team or a C-team player, you could end up with some pretty substantial problems. And that's really, what you want to avoid. But just be aware of that situation, and it goes pretty much for every contractors. If they're rushed, the chances of getting less than professional work is much, much higher. All right, so that is it for this week. I just wanted to get a podcast out and let you know and share that information with you. Hopefully you enjoyed it. If you know somebody electrically, maybe you're going to share these stories with them as well. Go ahead, If not, hey, I always encourage cross-training because, again, like I said in the opening of the show, it's one of those things where, you can learn about it and apply it to your own job. So, great things to do. Again, thanks for listening. Thanks to the BCAA, the Building Commissioning Association, for sponsoring the podcast. If you like the episode, the best thing you can do is pass it along. I appreciate each and every one of you. You're the top 3%, as I've said many times. Those people who are trying to continually improve themselves and listen to great content, and hopefully that's exactly what you're listening to right now. I appreciate some of the feedback. If you want to give me feedback, or if you like what you hear, or you didn't like what you hear, or you disagree with what I hear, please drop me a line. You can reach me at matt@buildingx.co if you want, and I really appreciate anybody who's willing to leave a iTunes review, 5-star review, or something, review me in iTunes. I'd really appreciate that, and I'll give you a shout out when I see it. So, also, if you want to follow me on Twitter, it's at BuildingX. I infrequently Twitter, but I do get an occasional tweet out. And if you want to connect with me on LinkedIn, I'd love to connect with you as well. That's at Matt Nelson, PE, on LinkedIn. So, remember, until next time, know what you build and share what you know.